Okay, so this is lesson 1.7, day 2, inverse functions. Here's your warm-up. So our fx and g of x inverse functions, you have to do this algebraically using composition of functions, same with this one. So pause your video. It'll probably take you about 5 minutes work here, but do it on your own. I'm not going to go through it in much detail. Okay? If you need help on this, you'll need to come to tutoring. And so moving on, what you should have got was this. You're doing f of g of x, so g of x is going in for that x. So we've got 2 times that big hot mess, minus 5. Distribute the 2. You've got 2 over 2 times x, which is 1x. 2 times 5 over 2 is 10 over 2, which is the same as 5. Yeah? So here you've got 1x minus 5 minus... something's gone wrong there. That doesn't equal x. Where have I gone wrong? That should have been written as plus, shouldn't it? That's the problem there. That was 2 times 5 over 2. That should be a plus there. That's why it looks wrong. Okay, I was about to say, because that doesn't cancel out. And if you go the other way, this one might be a bit easier. We're writing g of x, so we're writing, maybe not. We're writing g of x, and where we see that x in its place, we're putting 2x minus 5 in for that x. So we've got 1/2 of 2x minus 5 plus 5 over 2. Distribute the half. You've got 1/2 times 2x, which just gives you 1x. 1/2 times negative 5 gives you subtract 5 over 2. Then you've got this plus 5 over 2. Those cancel, even though they're ugly, they still cancel. You're left with x. So those ones are inverse functions. And here we go. Don't forget when you are squaring things, you FOIL them. So this gives you x squared plus 3x plus another 3x gives you plus 6x. Plus 3 times plus 3 gives you plus 9. Subtract 3, no. And you earned this one. Is it any point in us working out k of h of x? No. If h of x didn't cancel k of x, they're not inverse functions. We don't care. We don't even going to look to see if k of h of x gives us x. It doesn't matter. So moving on. Right, your homework, it's actually, you can print it off as a worksheet. It's from an old textbook. Actually, it might even be from this textbook. You can, if you're feeling super lazy, skip 39, 41, and 43. I would look at them and make sure you really know what you're doing. Do not skip numbers 59 and 60. You'll be sad if you did. Okay, super important. So let's look at what we're looking at today. More of a challenge. Do you want to try these? These are horrendous. Oh, what fun working with fractions. This is more difficult than you're going to get on your test, don't worry. But if you want a challenge, you go for this. Pause your video, give it a go. See where you get to. Now, remember, you're going to end up with fractions inside fractions. Like when you put g of x in here, you can have 1 over x plus 1 minus 1. Oh, the plus 1 minus 1, those are cancelled nicely. What about when you but you'll still have 1 over x here, and you have to know what to do with a fraction inside a fraction. And g of f of x, when you've got g and you put f of x, you'll have 1 over x minus 1. You need to know how to divide with fractions. So remember, dividing by fractions, you either say multiply by the reciprocal, or you say keep, change, flip. Keep the numerator as it was, change division to multiplication, and flip this one upside down. That's your multiplying by the reciprocal part. Okay? There's an alternative way of working with fractions. You can multiply by a carefully chosen form of 1. I'll show that in this solution. So if you had a go at them, here's your answers. Ha-ha! Putting in 1 over x plus 1 in here, your plus 1, your minus 1 cancel. Here we go. I've multiplied top and bottom by a carefully chosen form of 1. So I've got 1 times x over x times 1, and you can cross those out. Yeah, it's not very clear like that. I can see a lot of people going wrong. Same here. This is multiplying by a carefully chosen 1 as opposed to keep, change, flip. Or multiplying by the reciprocal, more likely to get the right answer. These ones turned out to be inverses. Please don't worry. I'm not going to give you anything. That's pre-AP. They'd give you that, not us. So, right. So let's have a look at another one. This one starting off, we're not looking to see if they are inverses. This one we're being told to find the inverse function. And then we've got the main focus of today, finding the domain and range of an inverse function. So step one, write y equals 2 times square root of x minus 1. Then flip your x's and y's over. So you'd write x here. So are we ready to square it to get rid of this? No. You can't, you have to square the entire side. So we're going to, you can divide that 2 out, or you could square everything. Square this entire side. That 2 is going to turn into a 4 when you square it. Whether it's here or whether it's here, everything needs to be squared. Now when you square that square root, this will give you x squared over 4, not 2. This has to be squared as well. This will give you y minus 1. So now we've only got one last thing to do. We've got to add 1 to both sides. So our inverse function, it was called f, so call it f. And write it. Now, find the domain and range of your inverse function. Oh, that's simple. If we looked at this, if this was any old function, if it wasn't called the inverse function of f, if it was just called, I don't know, m of x. So let's say we've got any old function and we're calling it m of x equals x squared divided by 4 plus 1. We've got no square roots, we've got nothing in denominators, so we're thinking the domain of this is anything you'd like it to be. It's all real numbers, and its range. How would you work out the range of this? What's the smallest y value that's ever going to come out? The smallest you're ever going to get from this is nothing, if x was 0 plus 1. Another way to work out the domain of this, the range of this, would be to graph that function. This is going to take it up 1. You're going to have this sort of thing. It's going to be compressed. But can you see the lowest value in the range is going to be up 1. The vertex is up 1. Hope you could still hear me then. I moved away to go and draw on the board. So from this, our domain is everything from 1 upwards, from 1 to infinity. That's what we think it is, but stop. No, this is not all right. We weren't just looking at any old function. We were looking at an inverse function, and there's a very important property you have to remember. When we have a function and an inverse function, remember the domain and the range switch places. The domain of our inverse function has to equal the range of our original function, and the range of our inverse function has to equal the domain of our original function. They have to be interchangeable. You can't just look at your answer and say, oh, that's domain is all real numbers. You can't look at that. You've got to say, right, let's look at my original function. Here's my original function. What was this one's domain? Because the domain of f of x is going to become the range of our inverse function. Okay, so let's have a look at this. The domain of f of x, well, we know that x minus 1 has to be greater than or equal to 0. So x has to be greater than or equal to 1. So our domain of this function is from 1 to infinity. The domain of f of x, that's going to become the range. Oh, that's what we just got over there. That was easy enough. In fact, this might have been an easier way to do it than that thinking we were doing over there. But what about the range of this? How would I find the range of this function? I think the easiest way is to kind of sketch a graph. Or you could think, what's the lowest value a square root is ever going to be? It doesn't matter what the x is. What's the smallest number, smallest real number you can get out from a square root? 0. So the smallest the y value is ever going to be is 0. Or you could graph it. Square root function moved off to the right and stretched a bit vertically. Okay, whichever way you've got to think of it, you've got to be able to come up with the range yourself. It goes from 0 to infinity. Now think about what this is going to become. This range, the range of our original f of x, is going to become the domain of our inverse function. up here, we were thinking the domain was going to be all real numbers, but it's not. Okay, the domain of our inverse function has to be the range of our original function. We've just worked out the range of our original function was not all real numbers. So, for our inverse function, this function here, the domain is not all real numbers. Look at it. It looks like its domain should be all real numbers, but it isn't. It has to equal the range of f of x. And our range of this is going to equal the domain of our original function, which was from 1 to infinity. Okay? It's easier to get it from here. In fact, both of those, this range was easier to get from here, and that domain was easier to get from here. You have to think about it, find the easiest way. So this is tough. This takes a lot of thought. You actually have to understand what's going on and stop and think. So let's try some more. Oops, that's the one we've just done, isn't it? Let's try another one. Okay, here we go. Find the inverse functions algebraically, and we're going to find their domain and range of the inverse function when we're finished. So let's have a look at this one first. We know its domain is x plus 4 has to be greater than 0. So x has to be greater than negative 4. Yeah? And its range, if I graphed it, we've moved to the left 4 and down 3. Its range, y values come out of it. The lowest this is ever going to be is 0. Take away 3, we're at negative 3. Okay, or do it by graphically. I've just done it 2 different ways there. Okay, so, but let's find the inverse function algebraically. So we're going to write this as y, switch over your x and your y, solve for y, add 3 to both sides, square them to get rid of that square root. Ooh, look at that, squared. Wow. Yeah, remember to FOIL. When you're squaring a binomial, you have to use FOIL. Subtract 4 from both sides, so that plus 9 is going to become... Hold on, where did that come from? That's a plus. All my pluses are missing. That's a plus 5, not a minus 5. You subtract 4 from 9, you end up with plus 5. Oh my goodness, that's wrong. Right, I have to go change that. That was driving me nuts. Okay, so this is our inverse function. Now, when you look at it, what would you say its domain was? If you looked at this, you say, oh, that's fine, its domain is all real numbers. But remember, this one's domain had to equal the range of that. So its domain, the domain looks like it should be all real numbers, but it's not. Its domain has to equal that one's range. Okay, there's another way of writing this function. Good grief, that's completing the square. Oh my goodness, you don't want to, oh no, don't worry about that. We're not going to complete the square right now. So now find the domain and range. So we've just worked out its domain, and it's not all real numbers, it's from 3 to infinity. How am I going to work out its range? Okay, just go back up here. The domain of your inverse, the range of your inverse is simply going to be the original domain, and that bit was easy to work out. This gets complicated, doesn't it? One more. That's the one we've just done with problems on it. Is there more on there? Okay, I haven't got question 4. Oh, here we go. Here we go. Let's try these two then. Try them on your own, and then I'll go over them. Domain, 3x minus 1 has to be greater than 0, gives you x has to be greater than a third. So that is from 1/3 included to infinity, and your range. The smallest y value you're ever going to get from a square root is 0. You'll never get smaller than 0. Otherwise, because you can't take the square root of a negative thing here, the smallest value from a square root is ever going to be 0, so this is going to be 0 to infinity. Let's find our inverse. Switch your x and y's, square to get rid of the square roots. You end up with this, add 1 to both sides, and divide by 3. So this is your inverse function. If you just look from here, you'd think the domain was all real numbers, but remember, we're going to have to make its domain equal the range of the original function. And its range is going to have to equal the domain of the original function. Okay? So this one, oh my goodness, wow. Let's look at domain of this first. 4 minus x squared has to be greater than 0, which gives us 4 has to be greater than or equal to x squared. If I add x squared to both sides, when you take square roots, x is going to be something to do with plus or minus 4. That's where things are going to change, but we're not sure where anything is. So plot plus or minus 2, the roots of this equation, plot the roots of this equation on a number line and think about it. Test each zone. I've highlighted the middle because I've worked that out. Test where this is true. If I put in the value here, -3, is -3 squared? Is 9 less than 4? No. If I try a value in the middle, like I tried x is 1, is 1 squared less than 4? Yes. So this value, this area is true. Try an x value here. If x was bigger than 2, try 10. Is 10 squared 100? Is it less than 4? No. So that's why our domain here. Now this is tricky, and there's going to be some of this to practice on your review. I'm trying to hint at you here. Don't skip this. Understand how we're doing this. We did one of these, back on day 2 or day 3 of the entire course. So that is our domain of this function. Right, let's go through this and find our inverse. Switch your x and y's, square both sides. I could add y squared to both sides and subtract x squared. Yeah. Added y to both sides, subtracted x squared. This is difference of squares. Do I need that? And I'm trying to solve for y. So I just want to take the square root of this. Well, that looks familiar. It's the same as the question. This is a difficult question. So my inverse function is this, which is exactly the same as the one we started with. It's an inverse of itself. So does this mean its domain and range, or all the domains and range of everything is this? What's the range of this function? Is this one's range from -2 to +2? Could I make this give me an answer that's -2? No. The lowest number I'm ever going to get from this is 0. The highest number I'm ever allowed to put into it is 2. Basically, what we're saying that this wasn't 1-to-1. We had to restrict it from 0 to 2. This is much harder than you need to do on the test, I promise. Maybe this part as just finding domain and range, but not this part. Okay, I'm going to have to stop for the day now. That was much harder than you're going to be expected to do on the actual test, so please don't worry too much about that. Here, I'm going to finish my video now. Hope you have a great day.